Hello guys, welcome back to my channel. Today in this session we are going to discuss about the logical classification of input data. So introduction to logical classification of input data. In this, the efficient processing and analysis of input data is very crucial. So it involves how the data is being organized as into a meaningful categories, which also enables effective visualization, interpretation, and manipulation. So in this picture, you can see how the data is being classified. So initially, we need to define the objectives, and then we need to determine categories, and then from the categories we'll outline the roles and responsibilities, and then we'll develop security practices. So finally we'll come into last stage, which is re-evaluate classification of criteria or process. So the types of input data which is being classified into raster data, vector data, 3D data, and sensor data. So in the first one, raster data, so it is also known as bitmap data, which also represents images as a grid of pixels. So in this data is commonly used for photographs and scanned documents and digital paintings. And in the vector data, as it represents images which is being done using mathematical equations and geometric shapes, so it is commonly used for logos, illustrations, and scalable graphics. So the 3D data, as the name indicates, 3D, which stands for three-dimensional objects and environments. So this data is commonly used for 3D modeling, animation, and virtual reality applications. So the sensor data, which represents information which is collected from various input devices such as cameras, scanners, and motion capture systems. So it is commonly used for interactive applications and real-time processing images systems. So the next is, so we'll see the main key differences, how it is raster data is different from vector data. So as we have seen, the raster data which represents the images as a grid of pixels, where each pixel has a specific color value. So which is also a resolution dependent, and it also appear pixelated when scaled. So vector data, which uses mathematical equations as we have seen earlier, so which is used to define shapes, lines, and curves. So it is a resolution independent, and it is ideal for illustration, logos, and other design elements that require clean and sharp edges. So the key differences is, the raster data is based on fixed grid, while the vector data is based on geometric primitives, and the raster data is better for photorealistic imagery, and while vector data excels at creating clean, scalable graphics. So we'll see what are the advantages and disadvantages of raster and vector data. So the raster data, as it is like digital photos, excels at capturing fine details and realistic textures. Whereas the vector data, as it is a graphics and illustration, resolution independent, and it can be scaled without quality loss. Whereas the raster data, as it can be memory intensive and difficult to scale without losing quality. But the vector data, as it can be scaled without quality loss, and it may struggle to represent complex organic shapes as efficiently as raster. So now we'll see what are the importance of data classification. So it also includes like efficient data management, informed decision making, and advanced capabilities. So efficient data management, so it provides proper classification of input data, which enables in efficient storage, retrieval, and processing, optimizing computer graphics workflows and performance. Whereas the informed decision making, so it includes like it provides valuable insights, and it also make informed decision about like design, rendering, and visualization. So advanced capabilities like it also includes structured data classification, which supports the development of advanced computer graphics techniques. So it includes techniques like machine learning, enabling intelligent and automated processes. So the next is techniques for classifying raster data. So it includes various techniques. So here I have included four. So the first one is pixel based analysis. So in this, it examines the individual pixel values, and it also determines the spatial relationships to identify the patterns within the raster data. And next is image segmentation. So in this, by dividing the raster image into distinct homogeneous, which similar regions or objects based on their similarities like color, texture, or brightness. And the next is supervised classification. So by training a model using a labeled sample data to automatically classify unknown pixels into predefined categories. So unsupervised classification, which means like grouping pixels with similar properties into clusters without prior knowledge. Like it also allows the data to reveal its own inherent structure and patterns. So the techniques for classifying vector data, it includes three steps. So initially the first is topological analysis. So in which we'll see like how the vector elements are connect and interact. And in the next step, that is geometric analysis, it focuses on inherent properties of the shapes. And the third one, as it is attribute based classification. So in this, it allows the grouping of vectors by their associated metadata, which enables the efficient organization and retrieval. So the metadata like color, layer, or type of the data. And what are the factors to be considered when classifying the input data? So what are the factors to be considered? So here the first is data characteristics. So before classifying the data, we need to know what are the data characteristics. So like input data such as size, resolution, dimensionality, and data type. And the next is application requirements. So we need to understand the specific needs and constraints of the computer graphics application that will use the data. So the next is workflow integration. Like it also ensures the data classification which aligns with the overall data processing pipeline and software ecosystem. So the last is performance consideration. So in this, we'll evaluate the computational and memory requirements for different data classifications. So which optimizes the system performance. So the conclusion and future trends in input data classification. So as we have explored all the logical data classification, so it's clear that in this field will continue to evolve and play a critical role in the future. So which the technologies will also emerge like machine learning and AI will drive new advancements in automated classification, while ongoing research will unlock innovative ways to represent and analyze the complex data. Thank you guys for watching.